Okay, this is section 4.4 in your textbooks. We're modeling with formulas. Go ahead, Robert. Go, Sal.
The CN Tower in downtown Toronto is the world's tallest freestanding structure. It was built in the 1970s as a giant radio antenna. Really, every year, thousands of tourists enjoy a thrilling ride to the top and a breathtaking view. Have you ever been up to the CN Tower? How far can you see?
All right. Just fact checking. It's not actually the tallest freestanding structure anymore. Anybody know what it is? Yeah?
It's the Burj Khalifa, is it?
No, it's the
Tim? Yeah, it's in Dubai, I think. Alex?
Called the Burj Khalifa.
Yeah, I think that's it. All right. In any event, it's pretty tall, right? We can't argue that it's not tall. How can you use formulas to solve problems? Have you ever seen a ship disappear over the horizon? This happens because of the curvature of the Earth. The higher you are about the surface of the Earth, the further away the horizon appears. The relationship between how high you are and how far you can see is given by the formula. So d is distance is equal to 2 times the square root of 3.2 times height, where h is height in meters above the ground and d is the distance in kilometers to the horizon. Use this relationship to answer the following. So how far can you see from each? Round your answers to the nearest kilometer. So from the 360-degree restaurant. So if we look at our diagram here, let me move that up. We can see that it's 351 meters high. So max, what do you think we're going to do with that height, 351, if we're asked to find how far we can see from each?
I'm guessing you're going to times it by 2. You're going to times it by, sorry. Okay. You're going to times it by 3.2 and you're going to find the square root.
Yeah, so in other words, we're going to substitute it in for h, right, and solve for d. That's it. Okay, that's the whole kind of idea of the lesson, is we're substituting in known variables and solving for the unknown. So if I did that, my distance would be equal to 2 square root 3.2 times 351. Make sure that that 351 is all underneath the square root. So now if we were to write this on our calculator, we're going to do this multiplication first inside the square root because of bed mass. Then take the square root and multiply by 2. Adam?
It's 1,255.
1,000. Sorry, 1,000.
256.
256 meters. That sounds about right to me. So from the top of the 360 restaurant, you can see just over a kilometer away, right? 1.2 kilometers. If I were to move the decimal place 3 over, 1.256 kilometers. So that sounds about right. So the sky pod observation deck, Stephen, how far can I see from there?
The sky pod?
Yeah.
You'd have to do 3.2 and replace h, that's 447. So you have to do 3.2 times 447 and get the square root of that.
Yeah. And what's that?
Sir, how do I get the square root on my calculator? So you have to
That
do
symbol.
There's square root symbol.
So when they do that, they always comes in here.
Yeah, so on your calculator, I think you need
Is it
to,
the second?
yeah, second function and then down here. Yeah, Adam?
1,599.
Okay, so just closer to 1.6 kilometers. All right, any questions there? Okay, how high would you have to go for the horizon to appear to be 100 kilometers away? So what am I going to do now, Nicholas? So how high? So what are we looking for?
We're looking for height, so I guess you'd have to do it backwards.
Right? So what would you do?
100
400 kilometers equals, that.
Right, so you would word that by saying you would substitute in 100 for the distance, right? Is equal to 2 root 3.2 h. Now this is a little trickier. We have to try and isolate for h. AJ, what do you think we should do?
I think you need to put it to the exponent of 2 and then divide.
Okay. You're close. We want to do something first, though. Not do work with the exponent first. Michael?
Divide 100 by 2.
Yeah, first we want to get rid of this 2, right, AJ?
Okay.
Right here. So we can cancel that out. So we divide both sides by 2. So we get 50 is equal to root 3.2 h. Okay, now we still have to do something. Okay, Adam?
50 to the power of 2.
Right, so in order to get rid of a square root symbol, we have to square it. Okay? That's how you can cancel the square root. All right? So 50 squared is 2500 is equal to, now this is just going to be what was in the square root. Okay, that's how you get rid of a square root sign, is you square both sides. Okay? And finally, last step, Matthew.
You're going to try and splitify the variable, so you're going to bring 3.2 to the left.
Okay, we could, but that'll make it negative, and then I'd have to divide by negative. So let's just leave it on the right. So what could we do next?
Divide 3.2.
Right, good. Okay? So that means then,
It's a little low on camera.
oh, thank you. That means then how high we'd have to go for the horizon to appear 100 kilometers away. We would have to go to a height of 781 kilometers. It's very, 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 very high. Yeah.
So as I miscalculated the first part, it seemed to square before it's multiplied. So the answer for the first two parts was wrong.
Oh, up here? Okay. Nobody was double checking Adam's math there?
I double checked, but I wasn't sure.
Okay, let me do it. Seemed like a reasonable answer. This should have been, sorry, 67?
Year?
No, the distance is, sorry guys, the distance is in kilometers. So this is 67 kilometers. But the height is in meters, so careful, they have different units, right? So this would be our meters, our height in meters, 781.
So points.
And then this one,
1.599.
okay? You guys should be trying this stuff on your calculators, right? Making sure you're getting these same answers so you know how to use your calculators. All right, any questions there? So, in order to see 100 kilometers away, we need to travel to a height of 781 meters. So, a little over or almost double the height of the CN Tower. All right, let's look at example 1 now. It says in geometry, exterior angle of a triangle is equal to the sum of the two opposite interior angles. So D is equal to B plus A. Okay, that's a property of triangles. The reason why that's true is because all three angles in a triangle is equal to 180, and this angle is also equal to 180. Okay, so that makes this, that gives us this property. Okay, D is equal to A plus B. It says rearrange this formula to express A in terms of B and D. So how would I rearrange this to express A in terms of B and D? Alvin.
A equals D minus B.
Good. Now, even though A was on the right-hand side here, and if you move B over, it would be D minus B, I can then just switch them because it's an equality, right? I can write it right equals left or left equals right. So that's why I wrote it with A on the left. Any questions there? Right, this is the same thing as A is equal to D minus B. Right, that's the same thing, okay? It says the circumference of a circle in terms of its radius is given by the formula C equals 2 pi r. Rearrange this formula to isolate for r. Joseph. Joseph, you? No? Why not? How do we rearrange for r? It's right here. Can you see this?
Yeah.
Okay, so what do we do to get r by itself?
You have to put it on the left.
Okay.
I don't know.
No idea? So we use opposite operations right now, okay? So right now, 2 and pi is multiplying by r. So how can we get rid of the 2 and the pi? How do we cancel it out, Joseph?
By dividing it
Yeah, by dividing it, right? So what do I divide by? What do I divide this by?
by 2 pi.
Okay. Good, so these go away. What do I have to divide this side by? If I divide the right side by 2 pi, I have to divide the left side by?
2 pi.
All right, so what's r equal?
C equals, no, R equals C.
R equals c?
No, R equals C over 2 pi.
Yeah, thanks to the guy behind me. Yeah. Okay, do you see why though, Joseph? This cancels out, right? This 2 pi divided by 2 pi is 1. So we're left with just r. I just switched the sides. I don't know if that's what's confusing you. Maybe I should have just left that on the right-hand side and done this. That okay? All right, C. The area A of a square is related to its side length L by the formula A is equal to L squared. Find the length to the nearest tenth of a centimeter of a side of a square with 32 centimeters as the area. Sal,
Yes.
what do I do?
Find the length. Oh, okay. So. I'm really confused by this. Okay. The square area is 32 centimeters, right?
Yeah, so that would be substituted in for which letter?
A.
Okay.
So 32 equals L.
Okay. Now what do I do?
You have to find the square root of 32.
Right, because if I take the square root of both sides, right? This square and the square root, they cancel, so I'm left with just L on the right is equal to the square root of 32. Does it make sense?
Yeah.
And L is in centimeters. You sure? You seem uncertain.
I'm certain.
You're certain? All right. See you on the next one. Okay, so there's our 5.66, which we got to. Square root of 32. Right? Example 2. Rearrange a formula in more than one step. The equation of a line relates y to x, m, and b. So we have this equation, and it says rearrange this equation to express x in terms of y, m, and b. So Who wants to try this one? Luca in the back. We want to rearrange to express x. So isolate for x, Luca. What do I do?
You have to cancel out the M and the B.
Yeah, okay, you're right. I got to get rid of them. So what do I do?
You have to move it around.
Yeah, so tell me.
Have to do Y minus B.
Good.
Then equal MX plus B minus B.
Yeah, so the b's cancel, right? The b moves over the equal sign.
Yeah, then you just have to cancel out the M and the X.
Okay, so what do I do? How do I get rid of this m?
You have to divide it by itself.
Good. Excellent. So my final answer then is x equals y minus b over m. Okay? You got it? Feeling comfortable with this? All right, I'm a little concerned, the hesitation here. All right, our key concepts. Formulas can be rearranged to isolate different variables. To rearrange a formula in terms of a variable, first we isolate the term that contains the variable. So what that means is the term, remember, terms are whatever is all multiplied by itself, that constitutes one term. When it's separated by a positive sign or a negative sign, that constitutes a separation in terms. Okay, so what they're saying here is first isolate the term, and then the last step you isolate the variable. To isolate the variable, we divide by whatever's in front of the term, right? Whatever coefficient's in front of the term. Does that make sense? Okay. That's it.